I hope you're doing good, grade 11s and grade 12s. Welcome to Maths and Science series. This is Alton once again. Today I will actually help you with a topic known as statistics. These statistics. Please don't forget to subscribe to the channel. Statistics. So when you talk about statistics, we are actually talking about data. That's the first thing that must come to your mind when you talk about something known as statistics. We are actually talking about something known as data. So what is data? Data is any collected information. So whenever you collect information, we call that data, right? That's very important for you to know. There are those of you who will be doing IT or computer science. You will talk about this a lot. So let's say we have 2 apples. Remember, I said data is a collected information. We have 3 bananas. Then we have 4 I tend to forget the fruits, and 10, let's say, grapes. So all of these, when your parent sends you to actually buy these things, it's like she's giving you what? She's giving you data. So data is what? The collected information. I hope you understood that. So when you talk about statistics, the first thing that you must know is that we are actually talking about data, collected information, right? That's very important. Okay, let's try to continue. Now, we have something known as the measure of central tendency. I call them 3 M's. 3 M's. Or rather, we say triple M. Yes. We have 3 of them under measure of central tendency. The first one is the mean, X bar, and we have what is known as the mode. This is the second M. Then the third M is the median. The median. So what is a mode? A mode is the most occurring observation or the most repeated value in the data set, in the collected information. Remember, then we have something known as the median. This is the middlemost or the middle value in the data set. Let's say we have 21 values. Then on the left we'll have 10, on the right we'll have 10, then in the middle it will be whatever value. So that becomes the median. So what is the mean? The mean is actually the average, or it is the sum of the values, in the data set divided by the total number of the values in the data set. That's very important. So these are measure of central tendency. You must know all of them. By you understanding these definitions, it makes you to understand or to be able to calculate mean, mode, and median, or to determine them. Okay? So please do not forget to subscribe. I remind you again, guys, please, I plead with you. Okay, let's continue with our work. Let's say we have 3, 4, we have 9, 2 3 1 9. Okay, let's just say 19, then 22. The first thing that you must do here in statistics, make sure that you work with a data set that is written from smallest to biggest. That's very important. That's very, very important. Or let me just do it like this. We have 1 2, we have 3. It's not 33, it's 3. Okay, let me try to erase everything. We cancel the 1, then this is the one that we're having. We cancel 2, then let's cancel the 3, so that you can be able to see the numbers or the values in the dataset that are left. We have 2 3 digits. We have 4. Let's cancel the 9. Then 19. We're actually writing our values from smallest to biggest. That's very, very important when it comes to statistics. Make sure that you do that all the time. So our data set is from smallest to biggest. How many are the numbers that we are having here? I'm just counting. Okay, we have 8 numbers. So for us to calculate the mean, this x bar is mean, or it symbolizes mean. It symbolizes the mean. So you're going to add all of them and you divide them by the total number of the data set. Then the answer, it will be your mean. I hope that makes sense. Then what about the mode? How many numbers that are repeated here? 3. We have 2 of them, therefore it's 3. That 3 is what? The number that is repeated the most, right? Now let's say we had something like this, but sometimes in a data set they can actually repeat more than 1 digit. So let's say we have 1 3 3 4 4 9. Now you can see okay, let's just say 19 22. Now you can see that we have 3 and 3, they are repeated, and we have 4 and 4. So what do we do when it's like this? When they want us to write the mode, what you must do, you write 3 and 4, then inside the bracket you write bimodal. It means that we have 2 modes. I hope that makes sense. But now let's say we also have one that is actually repeated. We have 3 of them now. But if we had one that is repeated 3 times, we'd actually write the mode as 1. I hope you understand that. So here, since it's 1 3 and 4, we have 3 of the numbers that are repeated in the same way, which is 2 1s, 2 3s, and 2 4s. We have 3 of them, therefore you write word trimodal. I hope that makes sense. All right. 1 3 5 11 17 21 27 29 34. Let me just count 2 3 4 5 6 7 8 9. Okay, we have 9 digits. I feel like you guys are not subscribing to the channel. Please do so and like this video, okay, as I am explaining. All right, we have 9 values here. This is what you must do. You count. Then the one that is in the middle is known as what? As the median. It is known as the median. Make sure that you work with your data set must start from smallest to biggest all the time. Make sure of that. So this is how you find the median. You count the number on the left and on the right in the same proportion. Then the middle one becomes the median. So this is our second data set. Then let's say we have 16, we have 17, 20, 29, and 30. How many digits, how many values in our data set? We have 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. Meaning these two here, we're going to do what? We're going to add them and divide them by 2. I hope you see the difference between the first one and the second one. So in order for you to find the median, you divide, you add the 2 remaining values, because if we would actually count 15 and 16, we'll never have the median. Therefore, we're going to take 4 on the left and 4 on the right. Then the 2 digits in the middle, we do what? We add them and we divide them by 2. Therefore, our median becomes 15.5. So this thing, you only do it whenever you have, is it odd or even? I forgot that. But this is what you do. 15.5 is your median. You put it right here between 15 and 16. Right? Yes. I can see that you are agreeing with me. You agree with me. You understand what I was saying. I'm glad. Just clap your hands for yourself. We have a measure of central, not measure of central tendency, where we pass that. We have measure of dispersion. So the term dispersion talks, it's when we're talking about the data that shows us how the data set is dispersed or the data set is scattered. You see, now I'm actually teaching you English. The synonyms of scattered is dispersed. Disperse, scatter. Write them down. I'm kidding. So the measures of dispersion, we have a few of them. We have range, and we have quartiles. By the way, we have 3 types of quartiles, but we're going to talk about them shortly. We have the interquartile range. Your teacher might actually, or in an exam, you may find something known as IQR, which is interquartile range, and we have something known as the percentile. This spelling is not correct. It's okay. Let me just restore my points right here. Okay, we have percentile. So go and ask your teacher about this one. I won't do it. So we have range. Range is actually the difference between the maximum and the minimum value in the data set. The difference, remember the subtraction, the maximum value minus minimum value. That's the range. Then what about the quartiles? Now we have 3 types of quartiles. Quartiles can be differentiated into 3, or distinguished into 3. We have a lower quartile. Then the second one, we have the median. It's one, or it's part of the quartiles. Then lastly, we have the upper quartile. I'll explain to you what quartiles are, but for now, just follow whatever that I'm saying right here. Lower quartile, it's Q1. Median, it's Q2. And the upper quartile, it's Q3. Then we have something known as interquartile range. So remember the range, the maximum minus minimum. But here, since we're talking about quartiles, it will be IQR. Remember, interquartile range equal to half, or Q3 minus Q1 over 2. meaning we subtract the quartiles, but Q3 minus Q1. We want to actually talk about oh sorry, what I was explaining semi-interquartile range. So IQR is just Q3 minus Q1, but semi-interquartile range is what? Is half of the IQR. I hope that makes sense, which is Q3 minus Q1. Or you can write it like this, Q3 minus Q1 over 2. But IQR interquartile range, it's Q3 minus Q1. But semi-interquartile range, this is the half of IQR interquartile range. I hope you understood that, guys. So ask your teacher to explain to you what percentiles are. We have 2, we have 7, we have 24, 100, 173, 194. Let's say we have 300 and 400. Then they want us to determine the range in the data set. So remember, it is the maximum value minus minimum value. Show them your formulas all the time. So maximum value is 400 minus the minimum value, which is 2. Then the answer is 398. So 398 is our range. I hope that makes sense. This is just easy stuff. They just need you to focus here as we are moving forward. Okay. Let's talk about the quartiles. I want to show you something very, very important where actually most of the learners are getting it wrong. But from now on, from this day onwards, you're going to get this correct. We have 3 of quartiles: lower quartile, median, and the upper quartile, right? So Q1 is lower quartile, Q2 is median, Q3 is upper quartile. Now, for argument's sake, let's just put 1 here. So how many values do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we have 9 values, meaning that we can take 4. But before you can find Q1 and Q3, start by determining Q2. You will never find Q1 and Q3 if you didn't find Q2 first. I hope that makes sense. So you take 4 on the left and take 4 on the right. Or you can check all of them right now. We have 9 digits in our data set. Therefore, you can take 4 on the left, 1, just use 1, 2, 3, 4, and you take 4 on the right. Therefore, 100 becomes our Q2. It means that it is our median. I'll just write it here. Then what is Q1? Now for me to find Q1, it is the median before the actual median before Q2. So I'm going to find Q1 before the 100. I hope that makes sense. Now we have 4 digits, therefore we don't have the median if we will take 2 on the left and 2 on the right, but we'll take 1 on the left and 1 on the right, then we add these 2. So we're going to have 2 plus 7 over 9, over 2, which is 9 over 2. Then our answer, it will be 4.5. That's our median. Remember, Q1 is the median before the actual median. Then Q3 is the median after the actual median. Median after Q2, it is Q3. So we're going to take 173 and 400. Therefore, we add 194 and 300. Then we divide it by 2. So 194 plus 300 over 2. Just use your calculator. Don't try to make yourself a stereo. Alright, so 194, it gives us 247 when you divide it by 2. 194 plus 300 divided by 2 is 247. So this is how you find them. You will never find, before you can find Q1 and Q3, find first what? The Q2. I hope that makes sense. Then let's say they wanted to determine what the semi-interquartile range. Remember, it is the half of IQR, meaning Q3 minus Q1 over 2. It will be Q3, we know that Q3 is 247 minus 4.5. Then you divide by 2. I'm just using my calculator, that's why I'm actually delaying. So it's going to be 121.25. So this becomes our semi-IQR. But interquartile range, this is just Q3 minus Q1. I hope that makes sense. So this is very, very important, guys. Very, very important. So if you understand this, please make sure that you like the video. So it will be an indication to us that no, these children, these little children are understanding what we are doing. Yes, you are a child, you are not a parent. Okay, we have 4, 12, 17, 21, 24, 30, 37. How many digits do we have here? 1, 2, 3, 4, 5, 6, 7. Okay, we have 7. 39. They want us to find Q1, Q2, and Q3. These are quartiles. Q1 is lower, Q2 is median, Q3 is upper quartile. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we're going to take, we're going to add these two here and divide them by 2. You remember that, right? Why? Because we cannot take 4 on the left and 4 on the right. We won't be having a median if it's like that. So we have to take 3 on the left, 3 on the right, then we add 21 and 24, divide them by 2. Then what will be our answer? Just use your calculator, don't wait for me. 21 plus 24 divided by 2, it will give us 22.25. Then what you're going to do now, you're going to actually put that 22.5 between 21 and 24. Let me just use a red color to put it here between 21 and 24. So it's 22.5. This is our Q2, our median. Then I'll actually write it here, 22. Okay, may use the white pen, 22.5. Then Q1, you know that it is the median before the actual median, right? Q1 is the median before the actual median, before Q2, therefore from 4 to 21. That's where we will find our Q1. We have 4 digits, therefore you can actually take 1 and 1 on the right, then we add these 2, divide them by 2. That will be our Q1. So 12 plus 17 over 2, going to have 29. You're going to have 29 over 2. Use your calculator. 29 over 2, is it 14.5, something like that? Yes, 14.5. Then Q3, we're going to take 24 and 39. So we're going to take what, the 24 here and the 39, then we divide them by 2. No, we add 30 and 37, we divide them by 2, sorry. So 30 plus 37 is 67. 67 over 2, it's 33.5. That's our Q3. I hope you're getting the gist of this thing, guys. For the semi-interquartile range, semi-IQR, it will be Q3 over Q3 minus Q2, Q3 minus Q1 over 2, or half Q3 minus Q1. That will be your answer. So let me show you the importance of knowing these things that we are actually doing right now. There's something known as the 5-number summary. 5-number summary. So we have something known as the minimum, meaning the minimum value, right? We have a lower quartile, which is Q1. We have the median, which is Q2. We have the upper quartile, which is Q3. And we have the maximum value, the largest number in the data set. So we use the 5-number summary to represent or to draw something known as the box and whisker diagram. And it's 3 marks for you to draw or to represent the data set in a box and whisker diagram. So it's very important for you to know how to determine all of these 5-number summary, mean all of them, and we covered them so far. So let me show you how to represent these things in a box and whisker diagram. Okay, I'm just trying to draw the box and whisker here, then I show you a few things, then we continue. And by the way, statistics is in paper 2. Paper 2. Someone will just ask, is it paper 2 physics or maths? It's physics. Okay. Yes, I said physics. You'll tell me if I'm correct or incorrect, or it's in all these subjects. This is a whisker and this is a whisker. These are arms, if you would like to call them. Then this is a box, as you can see. These are things that you see, so there's no need for me to explain them more. You can see this. Okay, so here, this is a minimum value. This is where the minimum value is indicated, or this is where you put the minimum value. And right here, this is our Q1, the lower quartile. This is our Q2, the median. This is our Q3, the upper quartile, and this is the maximum value. But in order for you to get 3 marks for representing your data set in a box and whisker, you must show us what the number line. That's why you have maths and science. We're going to show you guys on how to master this topic. Please like the video, okay? So we're going to take 6 numbers on the left and 6 numbers on the right, then we add the 2 numbers 2, 3, 4, 5, 6, then 1, 2, 3, 4, 5, 6, then we add 54 and the 55, then we divide them by 2, then the answer will be our Q2, which is the median. Okay, so 54 plus 55 over 2, you punch it in your calculator, it will give us let me try to use my calculator. 54 plus 55 over 2, it is 54.5. This is our Q2. This is our median, right? Therefore, we're going to take that median and put it between 54 and 55 right here. So we're going to put 54.5 here. This is our median, Q2, right? Then let me just write the 5-number summary here. This is the minimum, lower quartile, median, upper quartile, and the maximum value. We do have the minimum. Minimum is 16, right? There's no need for you to calculate it. It is the smallest number. The maximum is 99. Then our Q2, it's that 54.5. Then what about our Q1? Our Q1 is the median before the lower quarter, before the actual median. So we're going to take 2 on the left and 2 on the right, and we add these two. We divide them by 2. Therefore, it's going to be 41 plus 41 over 2, which is 82 over 2. It's going to give us what? 41. Then this is our lower quartile. Then we're going to take 2 even here. We're going to take 2 digits. And on the right, we're going to take 2, then we add 60 and 62. It's not always the case. Some other question will never actually need you to add the 2 values. They will be straightforward. So what is the answer here? Try to use your calculator. 60 plus 62 over 2, it's 61. Therefore, this is our 5-number summary. Therefore, by having 5-number summary, we can represent the data in the box and whisker, or in a box and whisker diagram. So we need to understand this. I hope you understood it. Okay, but the first thing that you must do in order for you to represent it in a in a box and whisker diagram, you must start by showing us the number line. There's a mark for this. If it's 3 marks, if you don't show the number line, you're going to get 2 marks. Therefore, we have 16, 41, 54.5, 61, and 99. Therefore, let's actually try to write a scale that is appropriate for the data that we have. Okay, our first number is 16, then our last number is 99. Okay, let's try to use if we can try to use, there's no scale that is incorrect. Any scale is correct, but your scale must be linear, if I can put it in that way. So 0, 15, 30, 45, 60, 75, 90, 105. Okay, we can end here, as we can see that the maximum number is 99. Okay, then this is what you must do. The minimum value is 16. So 16 is after 15 right here. Let me try to use make this line to be vertical. Okay, then we are done with minimum. Then the Q1 is 41. It's 41 is before 45. Okay, it's before 45. Then the Q2 is 54.5. 54.5. Let's try to put it right here. Okay, right here. Then we done Q2. Then Q3, our upper quartile, it is 61. So here's our 61 right here. Then we are also done with it. The maximum, it's 99. As you can see that we have 90 and 105. Let's say 99 is somewhere here. Then what you do, you join the middle 3 lines, as if you are joining them. You're drawing a a rectangle. Then you join those other ones that are far away from the 3 vertical lines. So this is 3 marks. This is how you must actually represent your information in a box and whisker diagram. So in order for you to do so, you must know the 5-number summary. That's very important, good people. I hope you understood this. If you didn't, please rewind the video and please like the video, and do not forget to subscribe and hit on the notification bell so that you will be notified when we upload new lessons. Okay, here's another example. They want us to draw a box and whisker diagram. Then you know that you start by writing what? The Q2. We're going to take exactly half of the numbers on the right and on the left. Then this is our Q2. Then you can write your 5 number summary in your working. Make sure that the teacher sees it. Q1, Q2, we have Q3 and the maximum value. We do have the minimum value, it is 82. Then the maximum value, it's 140. What about Q2? It's 121. Then Q1 is the median before Q2. So we're going to take 82 and 89, then 113 and 100, then 94. It's our Q1, which is our lower quartile, 94. Then here we're going to take 123, 128, 140 and 135. Therefore 132 becomes our Q3, the upper quartile. Make sure that you show this in your working. So these are 5 number summary. Make sure that you do so. Then you show us what the number line before you can try to draw the box and whisker. So the first number is 82 to 140. Let's use the scale of 30. It will be 90, 120 and 150, because the maximum value, remember, it's 140, right? Then 82, it's right here, 82. Okay, let me try to choose a red color. So before you can do this, make sure you show us the number line. So 82, let's try to show where 82 is. Remember, 82 is between 60 and 90. Let's just put it right here. Then Q1 is 94. 94, let's say it's there. Then Q2, it's 121. Make sure that your 5 number summary is on your working so that the teacher can see it. Then what about Q3? It's 132. 132 right here. Okay, then 140. 140, it's there. Then you join the 3 middle lines. You draw lines joining the other remaining 2. So this is our box and whisker. There's no need for you to write the minimum value, as long as you wrote your 5 number summary in your working or in your calculation, right? So this is how you represent your information in a box and whisker diagram. It's always 3 marks, or it can be 2. So we don't care about what mark allocation they will actually give us, but you must know how to find, or to represent the information in box and whisker diagram. Then it's very important, guys. This is very, very important. You will never find Q1 and Q3 if you didn't find Q2 first. So let's say you have 25, we have 47, we have 40, we have 34, we have okay, let me just try to erase this one, and we'll write we'll use other numbers to form our data set. Let's say we have 143, 171, 182, 155, 171, 150 and 188, 164, 180 and 100. Lastly, 190. So draw or represent this information in a box and whisker. Remember, the first thing that you must do, work with data set that is from smallest to biggest, right? Now we have something known as a standard deviation. This is standard deviation. This is the symbol for standard deviation, right? So these are steps for determining what standard deviation. but using a Casio calculator, I'm not sure with the other types of calculators. You press the mode button, then the second step you press the option 2, it's written stat, then you press option 1, which is 1 minus VAR, then you will see that table, right? Let me just show you this example. I'll follow all those rules, but it's very important for you to know them. Very, very important. And you can also determine the mean using a calculator. Same steps, but the last step, it won't be the same. They want us to determine what the standard deviation. What you will do, you press the mode button. After the mode button, you press option 2, which is stat, then you press option 1, which is 1 minus VAR. Then step number 4, you will see a table. Then you punch those numbers in your table. It will be 30 equal sign, 14 equal sign, 24 equal sign, 17 equal sign, 24 equal sign, 16 equal sign, 20 equal sign, 3 equal sign. Then the fifth step, you press an equal sign, then you press AC button, shift and 14, then you press option 3, and after that you press the equal sign. It will be 7.62. But if you didn't understand this, make sure that you go to your teacher. He or she will explain to you, or you just rewind the video. So, but these are the steps for you to determine the standard deviation or the mean. If you don't want to use the manual way, you want to use the calculator. Okay, let me show you something very important. Open bracket, mean plus the standard deviation, or one standard deviation, and mean minus one standard deviation. Okay, then the second one, we have a mean plus 2 standard deviation, and we have mean minus 2 standard deviation. 2 standard deviation. So there are questions that will require you to have the knowledge of these two guys. Okay, now the first one up there, as you can see on your screen, it is when you talk about something known as the mean. One standard deviation of the mean. One standard deviation of the mean. As you can see that the coefficient of the standard deviation there, it's 1. That's why we're saying what? One standard deviation of the mean, or one standard deviation from the mean. Then this one here, as you can see that the coefficient of the standard deviation is 2. We call it what? We call it 2 standard deviations. Standard deviations from the mean. So you will see how are we going to use these things in order for us to answer the questions that they might ask us. So these are very important questions. This is where many learners are getting these questions wrong. But from now on, if you can actually make sure that you understand this, you will never ever lose marks here. Okay, then after this thing, I'm ready for you to write this in your book. Then after this, I'll show you the questions that actually require you to have the knowledge of this. Okay, this is the question. This is question 3 from a past question paper. They're saying that the data listed below shows the distance in kilometers. The SI unit of the distance here is in kilometers traveled by cyclist on each day of a 12-day cycle tour. So this is our data set, right? Then 3.11, they want us to determine the mean distance traveled per day. Therefore, you can use your calculator to determine what the mean. So how do you use it? You use those steps that I use for determining what the standard deviation, but the last step you do not actually use it. But I think it's step 2 if I'm not mistaken. So as actually I'm not writing anything here. I'm using my calculator to determine what the mean. But you must know that they said that the mean distance, now distance here is actually in kilometers. So each and every number that I will get, I will write kilometers. So my answer is 115.47, not 47.47, but it is in kilometers, right? Kilometers, because this is the distance, the mean distance, and distance is in kilometers, right? Then 3.12, they want us to determine what the standard deviation of the data. Doesn't have any distance. Okay, the standard deviation, you know how to find the standard deviation, right? Then the standard deviation, it will be, okay, I will say AC shift 14, then it will give me 18.67. This is our standard deviation. You're done. It's 1 mark. It's as easy as ABC. Now 3.2, on how many days, asking us the number of days here, right? Do the cyclist travel a distance that is outside of one standard deviation from the mean? They're telling us which formula to use from those previous formulas I tried to explain, or was trying to explain. So 3.2, this is what you must do first. Standard deviation, or one standard deviation from the mean, x bar plus standard deviation and x bar minus 1 standard deviation, right? Therefore, what is our mean? Our mean is 115.47 plus 18.67, and 115.4 minus 118.67. Then you punch your calculator to get the answers. So 115.47 plus 18.67. Let me try to use my calculator. It will give us 134.14, and 115.47 minus 18.67 will give us 96.8. Therefore, they asked us a question. They said that on how many days. So we're not done yet. So how many days? You see, so this is what you must do before you can continue the question. This is what you must do. Then you take the smaller number on the left, which is 96.8, then the bigger one on the right, which is 134.14. Make sure that you understand this. Then right here, we'll write below or less. Then here you will write within. Then here you will write above or more. Then when you add below and above, you will have what? Outside. Make sure that you focus. Okay, so how many numbers here in our data set? How many numbers in our data set that are below 96.8? We have 82, we have 89, that is below 96.8, we have 94. So the numbers that are below 96.8, we have 3 of them. Then numbers that are between or are within 96.8 and 134.14. How many numbers that are between 96.8 and 134.14? 3, 4, 5, 6, 7, 8, 9, and 10. So these numbers are within 96.8 to 134.14, right? Then which numbers are above? Numbers that are above 134.14. We have 1 and 2, 2 numbers, right? Now the question, it asked us how many days do the cyclists travel a distance that is outside. This is what is actually we are focusing on, outside, the outside word. Outside, we add above and below, then it gives us what? Outside. So 3 plus 2, it gives us 5. Therefore, we don't just write 5. They asked on how many days, meaning it's 5 days. But if they said below, we're going to take 3. If they said within, we're going to take 10. If they said above or more, we're going to say 2 days. I hope you understand this. This is very, very important. I think we can move, we can continue. So if you didn't understand this, make sure that you rewind the video. So sometimes they won't say below, they will say less, but it's one the same thing as below. They won't say above, they will say more. It's one the same thing. Within or between. Outside is always outside, right? I hope you understood it. Then let's try to do another question, or what the next part of our lesson for today. Now we have something known as a variance. This is variance, meaning the variance is simply the square of the standard deviation. So for an example, let's say the standard deviation, let me write it so that it looks better. Let's say the standard deviation is 3, then the variance, we square the 3, it will be 9. So the square of the standard deviation gives us what is known as variance. I hope that makes sense. Then there are these questions where they will ask you to comment on the distribution of the data or the skewness of the data. This is what you must know. This is called the distribution of the data or the skewness. What you must know when it comes to this question, compare mean and the median. So if mean is equal to median, then whatever comment that you must say, it must be symmetrical skewed. If you compare mean and the median, then the box and whisker will look like this. Everything is equal, right? But if mean is greater than the median, it means that the distribution is positively skewed or skewed to the right. Then this is how the box and whisker diagram will look like. And as you can see that the lengths of these lines are not equal. Make sure that you do those things whenever you draw them. Mean less than median, it means that this is negatively skewed or skewed to the left. This is our box and whisker. Then you can see these lengths are not equal, as well as the median. You can see the position, and you can differentiate between these 3 box and whiskers. You can see the difference, that the lengths are not the same. They are only equal when we talk about the symmetrical skewed box and whisker diagram. So this is very important. Is also important. These are those free marks where many learners are getting them the answers. The answers wrong when it comes to the skewness of the data or the distribution of the data. What can we actually talk about now? We have something known as the estimate or estimation of the mean. They can ask you to estimate the mean. So this is what we're going to talk about right here. Then we continue, right? So there are 3 things that you must know when it comes to the estimation of the mean. So when we estimate the mean, you'll be given 2 columns like this. What you must do, you must actually expand your columns, as I am doing. Many learners are getting this wrong, but from today onwards, I trust that you're going to get correct answers when the question asks you to determine the estimated mean or to estimate the mean. Some other people, they just add and divide by the total number of values, which is wrong. This is what you must do whenever you're asked to determine the estimated mean. If you are given a table like this, what you must do, you write midpoint here, and here you write midpoint multiply by frequency. This is what you do. Let me try to extend my lines. Okay, So for us to get the midpoint or for us to fill the midpoint column, you add those two, then you divide them by 2. 0 plus 50 divided by 2, it will give us 25. You only do this whenever you determine the midpoint. I hope that makes sense. So 0 plus 50 divide by 2, you will get what? 25. I hope you are still following. For us to find the value of the second row of the midpoint column, you add 50 and 75, then you divide by 2. So 50 plus 75 you divide by 2, it is 62.5. Then 75 plus 100 divide by 2. I'm going to try to use my calculator here. 75 plus 100, 75 plus 100 divided by 2, it is 87.5. Then 100 plus 125, which is 225 divided by 2. So 100 plus 125 divided by 2. Use your calculator, not make yourself a staring. So what answer are we getting? We're getting 112.5. Then 125 plus 150 divide by 2. I'm trying to use my calculator right here. So 125 plus 150 divided by 2, it will give us 137.5. So this is how we find the midpoint column. Then for us to find the midpoint times frequency, you actually multiply. Okay, we only do this whenever we want what the midpoint, but don't forget to divide by 2 after adding the two values and so on. So for us to find the midpoint multiplied by frequency, you multiply frequency and midpoint as it suggests. So 1 times 25, it will give us 25. 2 times 62.5, it will give us 125. Then 3 times 87.5, 3 times 87.5, it will give us 262.5. Then 2 times 112.5 must give us 225 if I'm not mistaken, but let me just use my calculator. Yes, it is 225. Then 1 times 137.5, it's 137.5, as you know. Then what you must do now, you will write the total of frequency. Remember the total of frequency, the one that you're given. So 1 plus 2 plus 3 plus 2 plus 1, that's 9. So the total or the frequency column is 9. It is 9, yes. Then you write down the total of the midpoint multiplied by frequency column. You add all of those numbers there. You add all of them. I hope you are still following. So let me try to add 25, 125, and we're going to have the answer as 775. So this is the total of the midpoint frequency. Midpoint times frequency. Therefore, estimated mean x bar equal to the midpoint multiplied by frequency, then we'll divide by frequency. These are totals. So 775 over the total of frequency, which is 9. So the answer will be our estimated mean. This is how you solve or you determine or you estimate the mean. I hope it makes sense. So it is 86.11 becomes our estimated mean. But the first thing that you must do, you'll be given 2 columns in your table. You extend that table to have 4 columns. So you'll be given just these 2 columns, time and frequency. Then for us to get these 2, you do what? You extend your table. Then what you do, for you to calculate, you use the total of the midpoint multiplied by frequency. You divide it by the total of of the frequency. So 775 divided by 9, it will give us 86.11. That's our estimated mean, or that's how we estimated the mean. So I hope this makes sense. Please like the video if you understood this part. There's something known as cumulative frequency graph. Cumulative frequency graph. Some they call it ogive, and some they're saying it's ogive. As long as you know how to write it, doesn't matter how you pronounce it. So it's ogive. Some other people I had them saying it's ogive. It's one the same thing. Doesn't matter how you pronouncing it. But for you to actually have an ogive, you must have a cumulative frequency column. Let me just restore that information. For you to have an ogive or cumulative frequency, you must have what? A cumulative frequency row or column. I will show you. So this is how the ogive will look like. You draw it in a set of axes. It must have an S shape. Your teacher will tell you more about this. I won't actually sketch it, but I will show you how do you sketch it, like or tips on how to do it. But the first thing that you must have, you must actually extend the table again for a cumulative frequency graph. You sketch an ogive or cumulative frequency graph using what? Cumulative frequency column and the interval, the second part of the interval, but the teacher will show you this. So this is what cumulative frequency. You will never be given this. You'll be lucky if they do. So you must feel it. So it will be 3 here, then 3 plus 5, you will have 8. 8 plus 12, it will be 20. 20 plus 6, it will be 26. Then 20 plus 4, it will give us what? The 30. So this is how you actually feel the cumulative frequency column or row. So 3 plus, you see, this is how we adding our digits, or this is how we got our cumulative frequency table or column. You see, so this is how you're doing it. Then for you to sketch the ogive graph, what you do, you actually use this part as well as the cumulative frequency, but your teacher will actually show you this. Now this is a system of axes. On the x-axis you write what? The class intervals or the class in range, the first column on your table. Then here it is cumulative frequency, not just frequency. So your graph must have an S shape, right? That's very important, but the teacher will show you how to do it. But I hope you do have a clue of what's going on here. Or just try to sketch it on your own, but must have an S shape. Must start on in the ground. Okay, so here, let's say this is our cumulative frequency or ogive. Then they want you to estimate the median. They can ask you to estimate the lower quartile, or determine the lower quartile and the upper quartile. We are used in doing that whenever we're given a data set as numbers, not graphically. So when you are given a graph, I will show you right now how to find the mean, the median and Q1 and Q3. So this is the formula that you must use in order for you to calculate the median graphically, or using a graph. It's half n, or you can just use n over 2. It's one and the same thing. Then for Q2, this is what you must do now. Check, this is where the graph begins, or this is where the graph starts, and this is where it ends. So where it ends, you'll actually draw a line there using your ruler. It's 30, right? Therefore that 30, you will divide it by 2 all the time. It is our n. So it will be 30 over the 2. We'll have what? 15. Therefore that 15 is not our median, but you'll take your ruler, and on the y-axis you actually put your ruler there and you draw a horizontal line. That horizontal line must touch what? The ogive. Then you draw it vertically down. You draw it vertically down. So that 200 and something there will be our Q2. This is how you find Q2 or median graphically, or using a graph. So let me check here. So the difference here is 2. for us to get to 300. So it is 202, 204, 206, 208. Then I mean it's yeah, the difference is 2, so it's going to be 252. So it's 252, 254, 258. You see. I'm not sure if what I wrote here is correct, but you will correct it. 1 over 4n. You put the 30 here, then you punch it in your calculator. Then it will give us, just use your calculator, 1 over 4 times 30. It is 30 over 4, which is I'm going to try to use my calculator and not try to make myself a staring. It is 7.5. Therefore, the 7.5 is not Q1, but you just use your ruler. We can say that 7.5 is right on top of 5, somewhere here. Remember, it must not actually pass the ogive. Let me start it afresh. This is where our Q2, our Q1 will be when we draw the line vertically down. So that's where our Q2 is. Sorry, the difference here is 10, not 2. It's 10. So all of these answers of mine will be incorrect because I used 2 as the difference. I used 2 and it's supposed to be 10. So since I used 2, it will be 150. You can say 157 or something. But not forget to fix that mistake. So it is 10, 20, 30, 40, 50. So the difference is what? Is 10. From 150 to 200, it is 10. I hope that makes sense. I used 2. I don't know what happened. But please try to fix that. Okay, so Q3, this is the formula for you to find Q3. So where there's n, you're going to substitute that 30. Therefore, the answer will not be Q3, but use your rulers to do it, to show us where Q3 will be. So this is the formula for Q1. This is the formula for Q2 whenever you are using a graph. And this is the formula for Q3, which is 3 over 4n. So this is very, very important for this. So this n, it is where actually the graph is ending. Right here. Right here. So you're going to take that 30 and substitute it where there's n. I hope that makes sense. Therefore, try to do this on your own, then to see what your answer will be. And remember, my Q1 and Q2, they are incorrect because I said that the difference is 2 instead of 10. Remember, from 200 to 250, it means that the difference is 10. It is 210, 220, 230, 240, 250. Hope that makes sense. So this is where, this is what actually you must know when we talk about Q1, Q2, and Q3 graphically. So please don't forget to subscribe.